Particles are really cool. They instantly set the mood. However, they can be really difficult to control. But what if I told you there's a way you can make particles follow any path whatsoever, any path that you want? No matter whether you're a dev or you're just a gamer interested in how it actually works under the hood, in this video I will explain how that works. In my game dictatorship simulator, I have this political graph, and for that I needed particles that follow a very specific path. Unfortunately, in Godot itself, it's kind of hard to do that. You just have those physical properties like wind, gravity, and that's really cool. But if you need a very specific path, then it just doesn't work. In most game engines, the path that particles take is determined by a shader, and so if you want to have a custom path, you have to write your own custom shader. This may sound daunting, but shaders are actually pretty simple. Having a simple shader where your particles follow a path that you give into the shader is maybe 8 lines of code. If you think about it, every path can just be divided into individual segments, and then every single one of those segments is defined by 2 coordinates, the start coordinate and the end coordinate. And so if we just take all these coordinates and we write them into a list, or like you call them in computer programming an array, then we have a path defined. Now, when I'm talking about arrays and like iterating over arrays and getting elements from arrays, all that I mean is that we have a list of numbers and we go through that list one after the other. So all we need the shader to do is to increment that number, the so-called index, over time. So at first it gets a first coordinate, then it gets a second coordinate, then it gets a third coordinate, and so on. That's really all we're doing here. First, we just define this as a particle shader, so Godot knows what's going on. Apart from that, particle shader just has 2 parts. Start, which is run once when the particle is spawned, and process, which runs every frame. So this is just code that is called by the engine. The basic idea is that we do our one-time setup in start, and then we update it every frame in process. The first part is easy. We just define a path. The exact syntax here is not super important. It's just like the list we saw in the animation. The first one is X, the second one is Y, and the third one is Z. But how do we update it? How do we actually set the position of the velocity or whatever in a shader? Well, it's actually pretty simple. Every shader has these magic kind of variables, and it's called transform3. Now, why it's called transform and not position doesn't really matter here. All you need to understand is that transform element 3 is the position of the particle. By setting that equal to the first element in our path, we spawn the particle at that position. But how do we update that? For that, we somehow need to tell the shader to iterate over that array we define. To do that, we can just store a number inside this custom variable. Every particle has its own custom variable. So this is set once. It's kind of like a per particle memory. Then what we can do is we just increment this by 1 every frame, meaning add 1 to it every frame. Then we get that element of the list and we apply it to the position. So as you see, this kind of works, but our particle is kind of teleporting from one spot to the next spot. It's not really a smooth motion at all. What we need is, if we have a starting coordinate and an end coordinate, is we somehow have to invent the in-between steps. So this might sound really complicated, but this is actually something that shaders do all the time, and we can totally do it with the array that we have right now. But there's a much, much, much cooler and more interesting and easier way to do it, and that is to use textures. If we look at a single pixel, it's actually made out of 4 individual parts: red, green, blue, and alpha, or transparency. Because computers can only store numbers, every single one of these things is a single number. Now, there are different kinds of numbers it can be, but we're gonna use a floating point number between 0 and 1 for reasons which will become more apparent later on. Now, the important thing here is that we can actually set this number to anything we like. Like, for example, our coordinates. What would happen if we set red to our x coordinate, green to our y coordinate, and blue to our z coordinate? What we've done now is basically take a single coordinate in 3D space and then code it into the color of a pixel. Every individual color stands for one specific coordinate in 3D space, because the red, green, and blue values correspond to the x, y, and z coordinate inside of that space. If we now take multiple of those pixels and put them in a strip, we have effectively encoded any number of coordinates into a texture. You can make the strip as long as you want, and every pixel represents exactly 1 coordinate. And this is a key to just bending particles to our will and have them follow any path whatsoever. In the shader, all we need to do is to pass in a texture assembler. We're using a uniform here. The only thing that matters right now is that a uniform is an input to a shader. So that is something that we can set from the outside, like for example, from our code. This just allows us to define a texture that we created outside of the shader and bring it to inside of the shader. We can then feed this texture assembler a number between 0 and 1, which is also known as UV or UV coordinate, and it will give us a color at that point already interpolated, meaning it's already mixed. So if we're in between two colors, the color that we get is already a mix between those two colors. And if you have two different colors, so like red here and green here, then if you're very close to red, then it will be mostly red. And if you're completely at green, then it will be totally green. But anywhere you are in between, you get the in-between color mixed between red and green. Automatically, already done. And the absolutely mind-bogglingly coolest part of this, and this is why I love computer stuff, is that because we encode our coordinate in the color, when we get an interpolated color, in-between color, that is our in-between coordinate at that point, because the color of the pixel is our coordinate. So an interpolated pixel is an interpolated coordinate. But what is that magical number between 0 and 1? If you think about it, we need something that's 0 when the particle just spawned, and it's 1 when the particle is about to despawn. So imagine this. Imagine that I knew the age where I died. Let's say it's 70, okay? Then I could, every year, take my current age and divide it by 70, and I would get exactly this number between 0 and 1. It would be 0 when I'm born, and it would be 1 when I'm 70. So we can do the same thing for our particle. We can take the lifetime of the particle, let's say it's a second, okay? And then when the particle is 0 seconds old, then the number is 0. And when the particle is 1 second old, then that number is 1, and the particle is about to despawn. And so we exactly get this number between 0 and 1 that we need. So we need to know two things. We need to know the time that has passed since a particle was spawned, and we need to know the lifetime of the particle. And luckily, we get both of these things within the shader, as you guessed it, magical variables. First, figuring out how much time has passed. We have the magic variable time, which is seconds since the game has started. So if we want to know seconds the particle has been alive, we just take the value of it at spawn, and then every frame we subtract it from the current time. So then we get the difference between the spawn time and the current time, which is exactly seconds that the particle has been alive. We also know how many seconds a particle will exist, that is lifetime. So we can calculate how far along the path from life to death the particle is, the lifetime fraction. Then what we do is we set the spawn point. So the spawn point is just the texture assembler at position 0. Now the texture assembler expects a 2D texture, so it wants an XY coordinate basically. But we only have a one-dimensional texture strip of pixels, so the Y dimension is completely irrelevant for us, and we just set it to 0. And then whatever the texture assembler returns at that point is the color value at that point in time, which again corresponds to our position. So we can just set our position to that color value. So when we say here XYZ and then equal RGB, what this means is that we set X to the red value, green to Y, and so on. And now it's working. And this is how we can implement custom particle paths, not just in Godot, but in most game engines that have GPU particles. I hope you liked the video. I hope you learned something new. And if you find the idea of a deck builder where instead of directly attacking the enemy, you manipulate the political system so the system destroys the enemy for you interesting, then maybe wishlist my game on Steam. See you next time.